Awesome. Thank you very much. I'm so happy to be here and follow after Dan. I get the privilege to represent the engineering side of Microsoft's AI Red team. And today I'll be talking about accelerating our operations using the toolkit. If I can figure out the clicker. All right. Okay, so in the next 20 or so minutes, I'll give an intro to PyRIT, what it is, why we built it, and how the components are set up for a typical red team workflow. Then I'll talk about 2 case studies about how we use PyRIT to accelerate it on the AI Red team, and end with a discussion of some challenges that we faced going into that. And then I'll end with some further learning resources. So my hopes are, after today's session, you'll have a better understanding of the strengths and limitations of this particular operational tool, but you can also see tangible examples of how we've used PyRIT to draw conclusions of how you can use automation in your own red team workflows. And hopefully you will be inspired to contribute back to the project and to open source in general. We really want to further the learning and contributions to our field. Okay, so can I get a show of hands of folks who have heard of PyRIT before? Wow, okay, that surprises me every time. I feel like a little celebrity up here, thank you. So PyRIT stands for the Python Risk Identification Tool for generative AI systems, and it's an open source Python library that we've built to empower really anyone who's testing these generative AI systems to proactively find risks. And so this toolkit was born within our AI Red team. Actually, Gary Lopez is our esteemed author, so shout out Gary. And we open sourced this toolkit in February of 2024, so we could share that goodness with the world and, like I said, have that collaborative energy within the field. And before I move on, I'd like to note that this guy above me, this is our mascot, Roki. Any pronouns, really fluid, can take any sort of, representation. We have them as a pirate up here, but really we use Roki in every single situation. So ask me later why we love raccoons on the AI Red team. I'm happy to go into that. So why do we think PyRIT is useful? First, like I've really belabored the point here, to share our red team expertise out into the world and really invite others to create that with us. The second is to enable efficiency gains to use existing components and also increase reliability so we can automate those components of red teaming and configure and reuse them as we see fit. And the last is to allow for exceptional flexibility. So depending on what endpoint you are red teaming, regardless of modality, we want to support that and have these attack techniques built in. Okay, so I'm going to quickly go over the components just to make sure we're all on the same page, but you can think about PyRIT as automating the red team operation workflow. So, okay, my animations are working. We love that. Okay, so we're going to start with data sets. So every operation begins with a data set. What prompts will you send to the model or the generative AI system at large to test your harms? So we have the ability to either ingest from a local data set that we've created or connect to public data sets that are available online. And next, when we've thought about what our data sets will be, we think about what sorts of attacks we want to run. So we have single turn attacks and multi-turn attacks within PyRIT that are already configured. As we've talked about before, we have the configuration for the crescendo multi-turn attack within PyRIT. That's a great example that many have used. But we also have different single turn attacks. So we think about putting the endpoint into a specific state of mind. You can think about role play, for example, as a single turn attack. And we have these different basically adversarial algorithms enabled there. So the middle component, which is converters, this is if you want to think about how can I convert a single prompt into a different form. So we have different word level converters, such as translating to another language, or we have token level converters of base64 encoding, for example. I'll show a little bit more examples in my case study, but you can think about basically transforming transforming the prompts into different forms through converters. The target is just PyRIT speak for what the endpoint is. This is how we connect and send inference to the endpoint. And so we support all different sorts of modalities on the screen, and we're building more support into the image, video, and audio space, as well as text. And lastly, once you have those results from inference, how are you going to determine whether they're harmful? We have the capability to evaluate these responses based off of custom scores that relate to your use case. And then underlying all of this, we have the memory component. So on the AI Red team, we tend to use an internal Azure SQL database for our components. And then we can share these findings between our operators, which now our team, I think, is 32 people strong. So we really need this sort of sharing capability. And then last, the notebook is not really a architecture component per se, but it's how we have all of our documentation, our blogs, and our cookbooks, which are basically recipes for some common scenarios that you can use with PyRIT. Okay, so now I'll go into some case studies, and I've chosen 2 model-specific operations that we've done in the last year. So I chose model-specific ones in particular, just because these have been increasingly common for us in the last year as more models are being integrated into Microsoft's AI platform. So that can be either Foundry or Azure OpenAI. And so that's where our focus has been. But by no means are these all exhaustive. I was talking to someone earlier this week. All of our operations are manual first, and then PyRIT comes in and adds automation where it can. So it's really a perk of speeding some things up when we are able to for breadth and depth of the operation. But keep in mind that there's more that goes into these case studies than I've covered today. Okay, so the first one I'm going to talk about is Sora, and this is Sora 1, which was released in February of this last year. You can see I've made Roki eat a croissant in a cafe in France here. So this is my favorite prompt to send when I'm testing with Sora. But interesting fact about this, I guess, model is OpenAI didn't release an API publicly with this, but we did have an API added to the Azure OpenAI service. So this is what we've been testing with. And this doesn't include audio. So a reminder, it's just the video component. But the operation overview. So this operation took around 10 days, so 2 weeks. This is a standard sort of workflow for us. We usually have 2 weeks to run through operations. We had 2 operators on this, myself and one of our colleagues, Catherine. And we were looking at different harm areas. I've outlined a few of the scenarios. So looking at inappropriate content, misinfo, copyright. The scope here was text input and video output, and we've sent the low hundreds. I don't know how much you can see behind my head, but low hundreds of PyRIT prompts to the model with automation here. So I'm going to just walk through the different use cases outlined basically by the components that I talked about earlier. So in terms of target, when we first were tackling this model, we didn't have anything that could support Sora already. We didn't have access to the API previously. And so we did something that wasn't ideal, but is kind of a common experience where we used what we could already to get started. So we have an HTTP target within PyRIT, which basically allows you to send HTTP requests back and forth from an endpoint. And then we had to have a custom callback function integrated there to handle the responses. So this wasn't really ideal because you had to do a lot of this sort of manually back and forth, downloading the video, trying to continuously pull the API to see if it was ready, things like that. And so while we were doing inference with the HTTP target, I was building a custom target that we could use for a smoother end-to-end experience. And this allowed us to really put in retries automatically for that video processing and download. So we didn't have to waste our time kind of manually interacting with those components and could just let it run in the background. So this is a fairly common workflow for us. We try to start with something that is a little bit less than ideal to get started. And then if we can put that ideal PyRIT integration in. In terms of data sets for this op, we ended up using a local data set that had specific harm category labels. And also we looked at prompt templates to feed the same prompts in with different fields. So what I mean by that, I highlighted labels because they are useful in terms of basically separating out your data set by components. So let's say I'm looking at 10 prompts that are probing for violence. I can send that and identify that with PyRIT, pull it in, and then run a series of tests specifically on that subset of the data rather than on the whole operation. And then for prompt templates, you can think about this. We had a couple of scenarios where we had basically fill in the blank things with different names of actors, different personalities. And so this is where the prompt templates came in, so we didn't have to rewrite those prompts multiple times. And the primary thing that we ended up doing here was just using PyRIT to send attacks in bulk. And so we call that the prompt sending attack, which is basically just direct inference. So nothing super fancy on the attack scenario here, but it did help us accelerate that aspect. And the last component I'll talk about is our converters. So we did a fair number of multilingual testing using our translation converter. So all of our prompts started in English. We used PyRIT to translate them on the fly into these languages that I've highlighted above. And we used that to look at different scenarios. While we were testing for our multilingual scenarios, we actually noticed that the model did not do a very good job of interpreting some of those languages. Our hypothesis was that it had to do with the Unicode understanding of that language. And so we created a new converter within PyRIT that basically took the text and then converted it into the Unicode representation. And we paired that with our token level converter that we already had in PyRIT to insert hidden characters within the prompt and see if that would influence any of the results. Okay, so the challenges that we had, I'll first start with our dataset iteration. So as you can imagine, the initial dataset is not the entire dataset that we're gonna send through the whole operation. And so a challenge that we had here is because we had to work quickly here, it was a little bit hard to have to reload and add new data to our Azure SQL database at the time, because there were some things that kind of needed to be sorted. For example, if I was adding metadata and adding harm categories to a specific prompt and I submitted that to the database, it wouldn't actually update it. It would say there's a dupe, so I can't add more metadata to this. So that's a challenge that we have to work through that wasn't really super addressed at the time. There's also, of course, the tight timeline for creating the custom target. And so our average 10-day turnaround, we have to bake in that dev time. Depending on how much the operator already knows about PyRIT, it might be hard to think about what scenarios would be enabled quickly with that. And so pending operator experience, it depends how often our operators actually use PyRIT within operations. And the last one I'll highlight here, I'm sure there's many more, but top of mind is that video scoring was not available at the time. So our couple of hundreds of videos were manageable enough for myself and Catherine to kind of work through in that time period. But if you can imagine, the more we scale, the more this automated scoring becomes important. So I added a little note that as of last month, we do have a video scoring solution within PyRIT. But I will note that's just capturing images within the video and then scoring that. So that works for content harms, but it may not work for things like misinformation in the audio, for example. Okay, so this is the meat of my case study. I'm going to talk about GPT-5. Our fabulous manager, Ram, created this image for us, and it's all over LinkedIn. But it was a great collaboration, and we ended up focusing specifically over here for the GPT-5 reasoning model API. So the time frame on this and the scope was really a lot different. I don't know where to stand so you guys can read, but we ended up reading or sending 1 million conversations through PyRIT rather than a couple of hundred. So the scope is already 5 times that what we, I don't know, math, 5 times that what we sent earlier. We looked at 18 different harm areas across these 3 different domains. And so I won't go into every single one, but you can think about these buckets. And we also had about 70, give or take, AI safety and security experts across the company working together over 15 days. So 5 more days than our previous operation. The scale was much different. Okay, so here I'm not going to highlight the target, but I will be going into some other different components. And the target is omitted because we already had something to interact with the OpenAI chat target. So that was already built in for us from previous operations. So first, I'll stand over here. I'm doing a little walk. Okay, so the reuse of data sets from previous AI red team operations became really crucial during this because we didn't want to spend all that time creating manual data sets, so we leveraged what we had from previous model operations and sent those through. One of the harm areas we were looking at was susceptibility to existing jailbreaks. So PyRIT has a suite of jailbreak templates that already exist from online, and we've built that into the tool. And so we were able to send those at least to evaluate the single turn harms for jailbreaks such as Do Anything Now or Dan's namesake. And then we could submit image and text input in pairs. So we did this specifically for content safety to add a little bit more context to that. This is just to highlight our multimodal capability for input, but this operation primarily was the text-to-text modality. And we used the prompt generation tactic of anecdoctoring for content safety as well. So this is a method for using in the wild examples to develop an attack prompt that can be used to create the same type of attack. So this is something we took from research and integrated into PyRIT to help us develop those adversarial data sets. And then lastly, we also leveraged many research benchmark data sets from the field for our psychosocial scenario. In terms of attacks, it's a little more varied here. So we have a capability to prepend entire conversations and send those along to the model or the endpoint. And so what we ended up doing here is to simulate previous interactions to explore multiple branches. So you can think about maybe having a conversation that's 3 turns with the model. At some point, you want to fork and think about a more coercive way of interacting, and then maybe a more persuasive way of interacting. And so here you would prepend the conversation for the first 3 turns, and that gives you the ability to control what the 4th turn is in a more branching specific way. We also had one of our operators discover that it's more effective to send a sequence of prompts one after the other as kind of a single attack without the need for the multi-turn adversarial prompt generation that we have in other multi-turn attacks. And so this smaller bullet right underneath that is to highlight that we created a custom multi-prompt sending attack specifically for this operation as well. Of course, crescendo, that's one of our more obvious multi-turn examples. But I will highlight that our other multi-turn scenarios we have within PyRIT are essentially leveraging an adversarial large language model to do that prompt generation for you. So the highlight of multi-turn is that you don't have to think about the whole conversation yourself. You can hand that over to an LLM and have it do the work for you. And the single turn attack that we ended up using here, I had mentioned previously before, but we ended up using the role play attack that we had with a slightly modified persuasion script. And this was for a psychosocial scenario to basically prime the model to think in specific psychosocial ways. So if y'all didn't read the bullet, this is essentially when someone will develop an emotional connection with the model in specific states. So this is a new area for us that's been really interesting. And then flip attack last is basically when you flip some words around within the context. And so that was another single turn example we used here. So now I'm going to talk through the converters and then end with scores. So first, we did more multilingual testing here, but we ended up testing with 21 different languages this time rather than the 8 that I had mentioned before. We had some word level converters, so leet speak and emojis are some of the tactics that we've seen have been useful. Previously, we have those integrated already within PyRIT. And then these are just some examples of encoding, but base64 encoding, Morse Unicode, ROT13, we have many different encoding kind of converters that we ended up putting in, as well as different encryption mechanisms. So Code Chameleon is a tactic where you can take a text prompt and then convert it more into a code-like interface and send that also to the model, as well as different ciphers. And for the intellectual property leakage scenario, we ended up creating a new converter, which takes the first letter of each word in your prompt and submits that to the model. And we found that that's actually useful for completing basically the sentence. We were testing to see whether or not we could get full text plagiarized by the model. So our operators had discovered this was useful and put it into PyRIT. And when we were testing for score or evaluating the responses, we first were looking at refusal. There's some harm categories where in order to elicit harm, you have to have it actually say something, not just, I'm sorry, I can't answer that. So most of the time when we're doing automatic scoring, we kind of use a layered approach here. We might start with refusal and filter out that initial set, and then we might add more custom scores on top. So the 3 that I have highlighted here, the bottom is the most clear one, definitive yes or no, did the model say that? But in the middle, we ended up adding a specific plagiarism score to address that scenario that I talked about for the first letter converter. And these had 3 different methods in there. I put them in parentheses, so you can ask me about them later, but longest common subsequence, Levenshtein distance, and Jaccard n-gram overlap. Those are some of the metrics we use to create this specific score. And then our last is to detect those custom attributes. So when we were looking at content safety, we had some scoring specifically to look at pronoun usage, detect ethnic traits that were in the response, or the ability of the model to assign race or ethnicity based on perceived statistical commonality of first and last name. All right, so our challenges here, we had a lot of different harm areas, and some were missing specific support from PyRIT already. So I would say that our offensive cyber capabilities are not as widely supported within PyRIT as some of our other harm scenarios, and that's something we're working on with our cyber-focused operators to build in. At the time, also for geolocation, personally identifying information, and intellectual property leakage, they had to add a lot of custom scenarios into PyRIT to support that, and weren't able to fit everything in during the operation. And psychosocial is also one of our newest areas, and so we're thinking about what that means in terms of automation and support there. And then for multi-turn attack utility, while we have the capability to use multi-turn attacks within PyRIT, a lot of our operators find that they need more control over the actual workflow. So sometimes the LLM that's driving the adversarial conversation will go off the rails and not really be super useful. And so we have been investing in that human in the loop and UI support, but we're not quite there yet in a very useful way. And then the last thing is around scoring specificity. So scoring is not one size fits all, as many of you know, it's non-deterministic. And so a lot of the times when we're scoring in bulk, we have to make sure that we enable that trust that it's actually going to be representative of what the response was so that we don't have to manually score. And so this is a big research opportunity for us to do more data-driven techniques. Okay, more challenges and limitations beyond Sora and GPT-5. So the first is around agentic scenarios. We just heard from Dan that there's a lot of work being put into automating different scenarios within agentic and more automated areas. But currently PyRIT is not super well equipped for that, so we're working on it. But at the time and currently, we haven't really had very many scenarios in our playbook since it's not as straightforward. The second, API-less support. What I mean here is it's really easy for PyRIT to connect to something that has an API, but a little bit less for things that don't, right? So we have the HTTP request to target, but we've also had basically like web browser interactions that we've done on our team that are focused on WebSockets, not HTTP requests. And so always in these scenarios, we're not able to use PyRIT super easily, and building that in is something we have to kind of do outside of the operation. And then last, it's the money question of anticipating operational needs. We can't read the tea leaves, and unfortunately, we don't know what's going to be most pertinent within an operation at any given point in time. So a lot of the times we end up learning from something that's missing and then building that in as we prioritize. So some things are missing during the operation, but we hope for the best. Okay, so I'm going to leave you with some resources. This first QR code will take you to the website for PyRIT, and then it'll link you to the other two. So if you only focus on 2 links, website, first QR code, and then this one will have our Microsoft AI Red Team landing page, and that'll take you to our video training series that we just came out with for learning more about AI red teaming, which you can share with your friends. I'm sure you all know what AI red teaming is, but more about how to use PyRIT within those scenarios, and then a paper from last year on lessons. And then I'll highlight that one of our integrations we've been really working on collaborating across other teams at Microsoft. We have an AI red teaming agent within Azure AI Foundry, which takes PyRIT's underlying scanner infrastructure and basically will help folks across the team look at where their product is in terms of a more benchmark converter way. So check those out, and thank you so much.
Hey, thanks for the talk. I have a question regarding this GPT-5 case study. So what do you make of the results? Is it just something you collect, or does it have consequences? So for example, if you notice that it's prone to prompt injections, you wouldn't use this model in something that, in an agent that calls the internet or something. Or if it's prompt jailbreaks, you wouldn't use it, or you wouldn't make it face a customer. So consequences or just collection of knowledge.
Sure. Yeah, so I didn't go into results much here because I was focused more on the PyRIT usage, but essentially what our workflow is after our operation is done, we will create a presentation or read out to that product team that's affected. And if it's, we categorize it into different critical, medium, and low risks. And so then we have that conversation with the team. Essentially, these are the ones that we think are flagged. And if it's critical enough, then we can pause a rollout of the product.
Okay,
Thanks.
thank you.
Thank you.
Hi, great
Hey,
talk.
thanks.
Super cool work. And I was kind of curious if you could talk more about the system prompt that you use for doing the testing. Like, do you change the system prompt to like maybe mitigate some of the harms when you're testing, or do you just use like a vanilla or no system prompt to test like the base model behavior?
Sure. So depending on the model, you may not be able to modify the system prompt, but if we can, some of our attacks will do that sort of baseline set. So when we're thinking about, let me see how I want to say this. Basically, we may modify it if we have the ability to, but a lot of times in PyRIT, it'll just set up the system prompt to put the endpoint into more of a, I guess, jailbroken mentality, right? So we have those attacks across, but it depends on the operation really, whether or not we'd want to do that. And sometimes if we're not able to modify it, it's just sending that as like an additional user prompt to see if we can influence the model behavior. That helps.